Hello! Alright, welcome. Okay, let's finish up the discussion about parametric equations here. I know some of you left off of here, but some of you guys, we just started this example here. So please catch up, okay? All we did was we plugged in values from 0 to 1, 2, 3, 4, 5. There was no end interval here, so I just put it up to 5. And here we had a limitation, right? There was a restriction at t. It has to be a positive, so we just plotted values that are greater than or equal to 0. And we plotted the values with orientation right here, okay? Now, we've done the first part, which is sketching with direction. Let's eliminate the parameter to write the corresponding rectangular equation, which means to write the equations using x's and y's, no t's, okay? Here we go. So you guys, I can see that you can realize, oh, which one's easier for you guys to solve for t? And I could hear some of you guys yelling out, yes, right here, maybe the x, right? Let's use the x. X equals root t. That means when you square both sides, you get x squared equals d. Oh, x squared equals d, huh? Now let's substitute that back into your y. Y equals 1 minus d. But what is d? It is x squared, so you're right. That does look like this, because you know that this guy looks like this kind of parabola, right? However, it has to fit the restriction that's here. So the domains have to be equal. That means you have to say this, and also that x has to be greater than or equal to 0. So you only get this part of the parabola. You can't have the other side here because it's out of the domain. Okay? Alright, so no part like right here. So you want to restrict the domain right here. It has to be this full. This is your complete rectangular equation. Alright, let's move on to example 22. It's a little bit unique because you can see that we've been working so far with parameters of time t. But now here, what do you see? You don't see t, time, anymore. You see theta. And theta usually means what? So our parameter has changed. Our parameter is now an angle. Angle, right? Okay, so let's talk radians though. Okay, I'm going to speak to you in radians because you better refresh your memory about radians. Right, so the first thing we're going to do is, okay, our instructions are here. Same instructions. Sketch with direction, then eliminate the parameter to write the corresponding rectangular equation whose graph represents the curve. Woo! Alright, so let's do this. Let's actually go ahead and write let's actually write rectangular first. I think you'll have a better idea, okay? Okay, let's do rectangular first. Let's rectangular. Alright. Rectangular equation. You're like, oh my god, like how in the heck do I write cosines and using y's and x's, right? So I want to refresh your memory a little bit. I know you remember this. This is the Pythagorean definition, right? Pythagorean definition, not the theorem, Pythagorean identity, right? Sine squared plus cosine squared equals 1. Now, that doesn't look exactly like that, but it looks a little similar, okay? Okay, so what's the first thing we need? X is cosine squared, right? Okay, cosine theta. So can we say x squared equals then cosine squared theta? Ooh! Ooh, okay, we're on the right track, okay? How about this little sucker here? You remember y is 3 sine theta. Is there any way we can like trick this to make it look like sine squared theta? So let's divide by 3. Oh, almost. Oh, but if we square both sides, we get y squared over 3 squared, which is sine squared theta. Oh, look, sine squared theta is in y, cosine squared is in x. So let's try plugging it in here. What's sine squared theta again? It's y squared over 9. What's cosine squared theta again? It is going to be x squared. Oh! Oh my god. Ding, 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 ding. What do you notice here? If you were to rewrite this into STD form, don't you get something like this? And I know you've noticed something. You're like, wait, I know what this looks like. It's a conic section. What conic section is it? Yes! Is it a hor or a verti? It's a vertical, right? Ellipse, exactly. With your major axis 3 and your minor axis 1. It's an ellipse, exactly. So all this nonsense right here, it's just an ellipse. What? Okay, it's just an ellipse. So you guys, let's actually graph this, right? If you were to graph this, you would know how to graph this, right? You would be like, okay, it's a vertical, so I know that I go up 3, I go down 3, because I can see my HK, my center is 0, 0, right? And you're like, I go to the right and left 1, 1, and I trace this nice ellipse, right? All All right. But you need orientation, right? Because this is not enough for us to actually sketch the parametric equation. So now, that was using the rectangular, okay? Now let's actually sketch using the parametric. And what do we do for parametric? We have to make a table. So this time we don't have a t, so we're going to use theta. Theta, and you have your x and y, which depends on theta. So go ahead and take some time. But you guys, what kind of values are you going to plug in? You're going to start at 0. You're also going to go, but now let's be strategic here. Let's use nice values. The values from your unit circle that you're used to. For example, pi over 4. How about pi over 2, right? 3 pi over 4, okay? Okay, and what else? We have also, let's keep on going a little bit more. You can do as much as you need, okay? But let's make a full circle or almost a circle, 3 pi over 2. And if you remember all these values, you're in good shape. But let's remind ourselves, what's cosine of 0? Cosine of 0 is 1. What's sine of 0? Sine of 0 is 0. Okay, pi over 4, root 2 over 2. Y is root 2 over 2, but times 3, so it's 3 root 2 over 2. Okay, how about pi over 2? Cosine of pi over 2 is 0. Sine of pi over 2 is 1 times 3, so it's going to be a 3. 3 pi over 4, it's cosine, so it's negative, negative 1, 0. Pi, I'm sorry, 3 pi over 4, shoot, sorry. It's root 2 over 2, right? But it's negative root 2 over 2. Sorry about that. I know you were yelling at me. Okay, just fill in the table as you know it. 3 root 2 over 2, but it's negative here, positive there, right? And it's negative 1 and 0 here, because cosine of pi, sine of pi times 3. 3 pi over 2 is 0 here, and negative 3 here. So you guys, if we were to sketch this, let's see what we would get, okay? Let's go like this, right? So 1, 0. Okay, that's 1. Root 2 over 2, try to guesstimate that value. It's about 1 point, try to plug it in your calculator and see what you get. And this guy is 3 root 2 over 2, and see what you guys get. You'll get something along here, because it's 45 degrees, right? And this is going to be your your theta equals 0. Your theta equals 0 here, your theta equals pi over 4. You have to write that just the way you do when you actually graph a parametric function, okay? And then when you go here, it's 0, 3, that's 1, right? 1, 2, and 3. Ah, okay. And you go here, well, it's like the same thing, but it's to the negative, right? This guy's 1, right? It's to the negative, but it's all around right here, right? And then here it's negative 1, 0, and the 0, negative 3. 1, 2, 3, somewhere here. Oh, and you guys, look what we get. But of course, we went this way, right? Orientation, orientation. You get your ellipse. I know it looks a little bit weird, okay? But you guys, because this one's a little bit more stretched out, but this one is a zoomed in, and this is the same. So they're both the same thing. I'm sorry about the shape, okay? I wish I did a better job with the graph thing, but I know you probably did better. Also here, you got to list. You got to actually write your theta. Your theta is pi over 2. What was it here? It's theta equals 3 pi over 4. You have to label it. Theta is equal to pi here. And theta is equal to 3 pi over 2. You have to label that, okay? And don't forget your orientation. And what does it do when it keeps on going? It just keeps on going around and around on this ellipse, okay? All right, that was a fun one. All right, now we've been going from parametric to rectangular. Now let's actually try to eliminate the actual rectangular and make it parametric, okay? That's part 3 for us. All right, so you guys, how are you feeling about parametric equations? So fun, I know, okay? Part 3, finding parametric equation. Find a set of parametric equations to represent the graph of y equals 1 minus x squared. And I know everyone's going, oh yeah, I know what that is. It's a quadratic, it's a parabola, it's a vertical, it's a hori, okay? I don't know. We're going to do all that using parametric, okay? Now, I'm going to show you 2 different cases here. 2 different cases, okay? Now, I show you 2 different cases because maybe they're the same, maybe they're different. Something might be different, but who knows, okay? We'll figure that out. All right, now, so first case, it says make this using this. This is rectangular, we got to make it parametric. But we already know that x is equal to t. Yay, one of them is done. So this is f of t, huh? It's in terms of time. Now we got to make this guy in terms of time. Well, if x equals t, I can already see that some of you guys are already finished. That means t squared is y. So here's your parametric. Easy peasy. And let's make a table. X, y. Okay, let's make a table. So we've eliminated the rectangular. Now we're writing into parametric equations, okay? So are there any restrictions here? Any t values that are out of the domain? Nope. So you just start with -2. You classic values, okay? -1, 0, 1, and 2. And when you solve for the values, stop the video if you don't want to listen, okay? I get -2, -3. I get -1, 0. I get 0, 1. If you're stuck on like how is she getting these values, please ask your neighbor right now. All I'm doing is taking this t and plugging into each, the x and then the y, okay? Here I got 2, -3. Here I got 3, -8, okay? And you realize that these are just coordinates, right? -2, -3. -1, 0, 0, 1. 2, -3. These are just coordinates, okay? All right. Now. Okay, so I got this so far, okay? So this is my parametric. How about using t equals 1 minus x? That means, what does x equal, right? What x equals 1 minus t, huh? Okay, so x is already done. Now how about y? You substitute in here 1 minus t, because now x is 1 minus t squared, right? So we got that. Oh, we're done! Actually, let's plug in all the way. When you simplify this, you get 1 minus 2t plus t squared. And when you simplify that sucker, you get 2t minus t squared. So you have your y in terms of t, x in terms of t. Woo! We're almost done, okay? Now let's actually make the same table, okay? Same, but a little different. We have a t, an x, and a y, okay? We have -2, -1, 0, 1, and 2. And when I plug in those values, here's what I get. 3, -8. I'm sorry I'm doing the calculation for you. Stop the video if you don't want to listen and you just want to check your answers with me. Oh, sorry. Oh yeah, that's good. -0 and 1 and -1, 0. All right. Now, you can actually plug this into your calculator and see what the difference is, okay? So I plotted this. Okay? So I've already taken the liberty and graphed it for you. For this one, here's what I get. I can see that at t equals -2, I get -2, -3. T equals -1, I'm here. T equals 0, I'm here. T equals 1, and t equals 2. And this graph goes this way, from left to right. See my orientation here? See my orientation? Okay, and my time is listed. This guy goes this way. Because you guys, look, I know that a lot of you guys were thinking, well, this is just, well, I know what this graph looks like, right? Are they the same? Based on whatever my x is in parametric form, are they the same? Because it's both representing this, right? But actually, they're quite different, as you can see. If I list this one, t equals -1 is here, t equals 0 is here, whereas it was here on this one. So making your parametric can change orientation, okay? And oftentimes your shape, okay? And at t equals 0, it's here. At t equals 0, it's here. So they're going at different speeds again, okay? And 2 is here, whereas 2 is here. And 3 is here, whereas there's not even 3 here, because 3 is somewhere down here. So orientation can change and speed can change. So don't make judgments, okay? All right, now I'm gonna do one that's really cool. Of course, when I come back, we'll do something really cool in class together, okay? So I'm gonna take this off, okay? Let's do one last example together. And this is this example here. Eliminate the parameter and obtain the standard form of the rectangular equation. What the factor, right? This one looks really tricky dicky, okay? But don't worry, it's not that simple. It's not that complicated. Okay, so we have, oh my god, we have h's, k's. We also have r's and thetas. What is going on, guys? Okay, eliminate the parameters. So we have some parameters here. What are our parameters? This guy right here, you guys, is just a constant. Okay, this guy is also a constant. What's our only parameter? It's these right here, which are angles. Parameters. Okay, these are our parameters. Okay, parameters. I'm sorry about the ugly spelling here. Parameters, okay? So our theta is our parameter. So you know what we're going to do? We're going to set the parameters, like this part right here, set those guys to be alone. Okay? All right, here we go. Woo! So changing it to rectangular equation means get rid of these parameters, okay? Okay, so let's write some basic things here. Let's solve for cosine theta. What's cosine theta? It's x minus h, right, over r. Now, can you explain to your neighbor how you got that? Stop the video and nudge. Give them a nudge, a poke. How about sine theta? Same thing, right? Y minus k over r. Okay. Now we're like, what is going on, okay? Now you got to keep all these little trick stuff from semester 1 in mind, okay? Now, I know sine and cosine I know that we've used something that's very useful earlier, but what can we do here? Okay, how about this? How about we utilize this again? Oops, cosine squared theta equals 1. Let's utilize that again. The Pythagorean identity, okay? Okay, so I'm going to square both, okay? So if I square both, here's what I get. Sine squared is going to be y minus k squared r squared, right? How about cosine squared? It's going to become x minus h squared over r squared equals 1. What? I know that's what you were thinking. You're right. It looks very similar to something here. Okay, what are we up to here, okay? Now, wait. Okay, what if, our values are the same here, right? So let's eliminate that too. So it's going to be y minus k squared. Oh my gosh. I know you're getting really excited. Plus x minus h squared. Maybe some of you guys can't read that, so I'll write it again with darker ink. Ready? Y minus k squared, because I'm multiplying everything by r squared. X minus h squared equals r squared. What the factor? Ding, 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 chitty, ching, ching. What is this, you guys? It's a equation of a circle. You know what's amazing, you guys? You've just learned something amazing here. This right here, you've not only just changed it to a rectangular, but you've also discovered that this is the way we write an equation for a circle in the parametric language. Okay? So get used to this right here. We're gonna use this a lot. Okay? Okay, so you know what I'm going to do, you guys? I'm gonna stop here and have you guys practice some. Okay, so basic sketches and also going from eliminating parameters and also eliminating rectangular, going back and forth from parametric to rectangular. Good luck!